Hi and Assalamualaikum everyone. Okay, so today we are going to continue with chapter 5, States of Matter, with a subtopic 5.2 liquid. Okay, so let's see the learning outcomes for this subtopic. So first one, you are going to explain the properties of liquids, which are shape and volume, surface tension, viscosity, compressibility, and diffusion. Okay, there are 5 properties of liquid that you need to know. And then you are going to explain the process of liquid, which are vaporization process and condensation process. You have to explain it using the kinetic molecular theory and intermolecular forces. Okay, and then you have to define the vapor pressure and boiling point. And last but not least, you have to explain the relationship between the intermolecular forces and vapor pressure, as well as the vapor pressure and boiling point. Okay, so now let's look into the physical properties of liquid. Just like I said just now, there are 5 physical properties that you need to know for liquid particles, liquid molecules. Okay, the first one is shape and volume. So you have learned this in primary school, I think in secondary school as well. So you already have an idea on what is the arrangement of the liquid particles. Okay, so you know that liquid particles has a definite volume but not a definite shape. Okay, which means that dia ada volume yang tepat tapi dia punya shape tu dia tak sama lah. Okay, alright, why? Okay, because particles, liquid particles are arranged closely together but are not rigidly. Okay, which means that liquid has strong intermolecular forces but not strong enough to hold the particles firmly in place. Thus, a liquid flows to fit the shape of a container. That's why liquid ni dia ada definite volume. So, volume dia sama, okay? Tapi dia punya shape tu dia ikut size, shape of the container. Contohnya macam ni. If you look at the volume, it all has 100 ml. But the shape is not the same. Okay, shape yang ini dia ikut shape beaker, yang ini dia ikut shape conical flask, yang ini dia ikut shape measuring cylinder. So this is the explanation on why liquid has a definite volume but not a definite shape. Okay, next, second one is viscosity. So what is viscosity? So viscosity is the resistance of liquid to flow. Okay, so the greater a liquid's viscosity, the more slowly it flows. So lagi tinggi lagi dia punya liquid viscosity dia, makin susah, makin perlahan dia flow. Okay, and viscosity decreases as temperature increases. So lagi tinggi lagi kita punya temperature, lagi rendah dia punya viscosity, which means lagi senang dia flow. Okay, so this has got to do with the intermolecular forces lah kalau temperature ni. Okay, so dekat sini saya tulis viscosity depends on 2 factors. First one is the size of molecule. So kalau size of molecule lagi besar, okay, the bigger the size of the molecule, the more resistance to the flow. Okay, maksudnya liquid tu akan jadi more viscous. Dia lagi susah nak flow. Okay, sebab size of liquid molecule tu lagi besar. Okay, and the second factors is intermolecular attractive forces. So the stronger the intermolecular attractive forces, the more viscous the liquid. Okay, so tadi saya bagi tahu viscosity of the liquid, okay, dia decrease as the temperature increase. Okay, so kalau temperature kita increase, apa berlaku pada intermolecular attractive forces kita? Okay, makin kurang lah. Sebab apa? Kinetic energy of the liquid molecule lagi tinggi. So, bila kinetic energy lagi tinggi, so liquid molecules dia move more actively, kan? Dia move more aggressively. So, dia punya intermolecular forces tu makin rendah. So, bila makin rendah, bila makin weaker dia punya intermolecular forces, jadi liquid tu akan jadi less viscous. So, dia akan easily flow. Okay, so that's it untuk viscosity. So kalau awak tengok kat sini, water dia ada lower viscosity compared to honey. So honey dia ada higher viscosity. So Kalau awak tengok honey, dia punya flow dia bila kita tuang madu kan, dia nak flow tu lambat. Dia flow slowly compared to water, sebab water ada lower viscosity, dia nak flow tu senang. Okay. The third physical properties of liquid is surface tension. So, apa maksud surface tension? So, surface tension is the amount, the typo of energy required to stretch the surface of liquid by a unit area. So, untuk explain the surface tension ni, so kita kena explain the liquid molecule, dekat surface of the water, as well as the liquid molecule dekat inner. So first kita explain dulu. So molecule yang dekat interior, so inner molecule, inner molecule, ini ada inner molecule kan, inner molecule yang ini are surrounded and pulled equally in all directions. So if you see this, so this is the inner molecule. So dia ni ditarik oleh ini, molecule yang bawah ni. So dia is pulled equally in all direction. However, molecule yang dekat surface, molecules on the surface are only pulled downwards and sideways, from the neighboring molecule, but not upward. So dia tak ada upward kan, tak ada kan? But not upward away from the surface, and thus pull in towards the liquid. So dia pull sideways and then pull inwards. So kat sini kita kata liquid surface is tightened as an elastic film. Sebab liquid dekat surface ni dia ditarik oleh sideways neighbor molecules dan juga downwards of the neighboring molecule. So bila dia tarik dari tepi dari bawah, so liquid molecule tu dia is pull in towards the liquid. Jadi dia punya liquid surface ni dah jadi ketat. It's tightened as an elastic film. So lagi kuat lagi intermolecular attractive forces. So the stronger the intermolecular attractive forces, the higher the surface tension. So dekat sini saya dah label ni. Particles at the surface, and then ini adalah particles within the liquid. Inner liquid particles. So contoh untuk surface tension ni, kalau you lihat kat sini, saya tunjuk water strider. So water strider dia boleh berjalan atas air sebabkan air tu dia ada surface tension. That's why you tengok kat sini water strider dia boleh jalan atas air macam ni kan. Dia tak tenggelam pun. Alright. Next, the fourth physical properties of liquid is diffusion. So what is diffusion? So diffusion is the process in which molecules tend to disperse from areas of high concentration to areas of low concentration. So kat sini lah proses diffusion kan. So ini kita punya liquid kita. So bila kita masuk dalam water contohnya, dia slowly disperse. Sebab ini kan high concentration. So ini kan low concentration kan. So bila kat high ke lower, dia akan disperse slowly sampailah dia fully diffuse dalam water. So the diffusion rate of liquid is much less than gases. Kenapa? Because liquid molecules are closely packed and has lower kinetic energy compared to gases. Because of the stronger intermolecular attractive forces between liquid molecules compared to gases molecule. And then last one for the physical properties of liquid is compressibility. So compressibility ni ability untuk kita compress benda tu lah kan, kita tekan benda tu. So kalau tengok ni liquid ni, so liquid ni dia closely arranged kan, dia punya arrangement tu closely arranged together. Dia tak rigid tapi dia closely arranged. So dia ada space but not too much space. So bila liquid particles ni kita nampak dia closely packed and have very little empty space between the molecule, so dia ni sebenarnya susah untuk compress. It is difficult to compress. Kita boleh compress dia, but compress only slightly. So dia punya compressibility tu very, very low compared to gases. So itu adalah that's the 5 physical properties of liquid. Okay, ada 5. Yang pertama shape and volume. Secondly is surface tension. Third is diffusion. Fourth is compressibility, and fifth is viscosity. Okay, ada 5. Okay, you have to remember the 5 physical properties of liquid. Alright, now, so untuk proses of liquid, okay, ada 2. Yang pertama condensation dan yang kedua adalah vaporisation. So first kita tengok dulu condensation. So what is condensation? So condensation is the process in which a gas is changed into a liquid. So maksudnya dari gas phase jadi liquid phase. Okay, so gas ni samalah dengan vapor, okay. So dekat sini saya tulis vapor molecules. So maksudnya gas molecules lah, okay. Alright. So, macam mana proses condensation ni? So, proses condensation ni biasanya kalau awak nampak dalam botol air kan. Botol air awak kan. Kalau awak biar je macam tu kan. Botol air, contohnya botol air plastik tu kan. Botol air yang ini, botol air plastik ni. Okay. Allah, buruknya. Okay. Botol air plastik ni. Okay, adalah air sikit kat sini kan. And then you tutup, okay. And then you biarkan lah kan, dekat mana-mana lah. Okay, tak kisahlah. Dia tak perlu panas pun. Dia dekat any room temperature pun dia dah boleh ada condensation. So you biar lama-lama. Lama-lama dia ada macam liquid kat sini kan. Okay. So, itulah proses condensation. Okay, di mana gas vapor yang dekat dalam botol tu, dia dah bertukar jadi liquid. So, dia dah melekat dekat tepi-tepi botol tu dalam bentuk liquid. Okay, so, kat sini, okay, macam mana proses condensation ni berlaku? Okay, so you bayangkan kita ada this container. Okay, and then container ni kita ada liquid molecules. Okay. Alright, and then kita ada few gas molecules lah, vapor molecules. Okay, so this vapor molecules ni, okay, dia ada kinetic energy lah. So, dia collide with each other, okay. So, bila dia collide tu, lama-lama dia punya kinetic energy tu makin decrease. Okay, so bila dia makin decrease, okay, so look at the first point, okay. Some of the vapor molecule ataupun gas molecule, they lose their kinetic energy during the collision or when the temperature is lowered. Okay, so makin lama dia punya kinetic energy makin berkurang, okay. Okay, bila dia punya kinetic energy tu makin berkurang, okay, dia orang lama-lama ni dah tak ada enough energy untuk remain as vapor molecule. Okay, sebab diorang ni makin lama, bila diorang ni punya kinetic energy tu makin berkurang, diorang punya energy untuk remain as gas molecule ataupun vapor molecule tu makin berkurang. So, apa berlaku? Makin lama diorang reach dekat liquid surface. Okay, makin lama diorang reach liquid surface dekat sini. So, diorang ni, bila diorang dah reach liquid surface, okay, diorang akan trap by the intermolecular attractive forces yang ada pada liquid molecule dekat surface tu. Okay, so kalau gas molecule kita ni cannot overcome the intermolecular attractive forces yang dekat surface of the liquid tu, this vapor molecule ni akan return as liquid molecule. So, dia akan kembali jadi liquid lah. So, that's how condensation berlaku. Okay. Ini according to kinetic molecular theory punya explanation. Okay. Next, kita tengok vaporization. So, what is vaporization? It is the process in which a liquid is changed into a gas. So, dia berlawanan lah daripada condensation tadi. So, kalau you tengok tadi, liquid, okay, to gas. Okay. So, liquid to gas adalah vaporization. Okay. Kalau gas ke liquid adalah condensation. Okay, so vaporization ni liquid ke gas. Okay. Alright, so kita nak tengok kita punya explanation kat sini. So vaporization ni dia occurs at any temperature and pressure. So as long as liquid molecules at the surface possess enough kinetic energy to overcome the forces of attraction that bind them with the neighboring molecules, dia boleh escape as vapor molecule. Okay, so vaporization ni dia occurs in two ways. Yang pertama adalah evaporation dan yang kedua adalah boiling. So evaporation ni dia occurs on liquid surface. So dia proses yang sama, okey, daripada liquid kepada gas, tapi dia hanya occurs dekat surface of the liquid. However, untuk boiling, dia occurs throughout the liquid. Dia berlaku bukan saja dekat surface, malah dekat inner liquid molecules pun undergo boiling. Okay, dia akan change the liquid phase into gas phase. So ada dua lah. So maksud vaporization ni proses change of liquid pergi kepada gas. Okay, so ada dua cara untuk vaporization, untuk tukar daripada liquid ke gas. Yang pertama evaporation, yang kedua boiling. Okay, so kita nak tengok vaporization explanation dia according to kinetic molecular theory. So liquid molecules ni dia closely packed together, okay, but not rigidly. So they move quite freely and collide with one another. Okay, but each molecule ni dia possess different magnitude of kinetic energy. Okay, so when kinetic energy is sufficient enough to overcome the attractive forces that bind them with the neighboring molecule, they will loosen themselves and escape as vapor. Okay, so dekat sini, okay, kita ada liquid kan? Liquid molecule. So liquid molecule kita ni dia collide with each other. Okay, dia boleh move freely lah. Okay, so setiap liquid molecule ni dia ada different magnitude of kinetic energy. Okay, so bila kita punya liquid molecule ni dia ada enough energy untuk overcome the attractive forces between the liquid molecules ni, okay, dia boleh escape as vapor. Okay, so itu maksudnya vaporization, daripada liquid phase tukar jadi gas phase. Okay, jadi vapor molecule. Okay, so apa factors yang affect the rate of vaporization? So yang pertama adalah surface area. So lagi luas lagi surface area, so the larger the surface area, the higher the chance for the molecule to escape from the water surface. So lagi besar lagi kita punya surface of the water, of the liquid, okay, lagi besar lagi chance untuk liquid molecule untuk escape daripada liquid punya surface. Okay, thus vaporization rate increase. Okay, faktor yang kedua adalah intermolecular forces. So, kalau weaker intermolecular forces between molecule, the faster the rate of vaporization. Sebab apa? Kalau dia punya intermolecular forces between liquid kita tu lemah, weak, okay, makanya liquid kita tu senang nak escape daripada liquid kepada vapor molecule. Jadi makin cepatlah ataupun makin tinggilah kadar rate of vaporization. Okay, and last but not least is temperature. So at higher temperature, the number of molecules that have enough kinetic energy increase to escape from the liquid surface to become vapor. Okay, so maksudnya kalau temperature kita makin lama makin increase, okay, kinetic energy of the molecule increase. Okay, maksudnya ada banyak lagi liquid molecule yang akan ada cukup kinetic energy untuk escape daripada liquid punya molecule ni. So dia akan bebas pergi kepada jadi vapor molecule. Okay, so bila macam tu vaporization rate pun increases. Okay, alright. So now bila cakap pasal vaporization ni, so vaporization ni awak tahu tadi kita dah belajar the process of liquid phase change into gas phase. Okay, daripada liquid molecules change into gas molecule ataupun kita panggil vapor molecule. So bila dia ada vapor molecule yang terhasil, okay, dalam closed container, maka adalah kita panggil term vapor pressure. Okay, so dekat sini kan, so asalnya dia jadi liquid, okay, dia liquid, okay, so bila dia ada enough kinetic energy, sufficient kinetic energy untuk overcome the intermolecular forces between the liquid molecules ni, okay, dia akan escape jadi vapor molecule, gas molecule. So vapor molecule ni dia ada vapor pressure. So maksud vapor pressure adalah pressure exerted by the vapor molecules above the surface of the liquid in a closed container. So penting ada closed container ni, okay? Sebab kalau awak ada So sebab apa? Kalau dalam closed container, okay, dia ada vapor pressure lah. Kalau dia open container, dia open system, vapor ni akan keluar, dia tak adalah pressure kat situ kan. Okay, so vapor pressure ni ada dalam closed container. Okay, so apa maksud equilibrium vapor pressure? So maksudnya adalah vapor pressure of a liquid is the pressure exerted by its vapor when the liquid and vapor are in dynamic equilibrium. So apa maksud dynamic equilibrium ni? So dynamic equilibrium ni bila the rate of vaporization, okay, is equals to the rate of condensation. Okay, maksudnya the number of liquid molecule sama dengan number of vapor molecule. Okay, maksudnya contoh, okay, kalau dua liquid molecule escape jadi gas molecule, okay, ini vaporization. Okay, so dua lagi vapor molecule akan condense, okay, jadi liquid molecule. So ni condense. Okay, so maksudnya dia punya number of liquid yang escape jadi gas molecule tu sama dengan number of gas molecule condense jadi liquid molecule. So itu kita maksud dia dah capai dynamic equilibrium. Okay, so dekat sini, alright, alright. So maksudnya kalau dia dah kalau rate of vaporization is equals to rate of condensation, maksudnya vapor pressure tu equilibrium lah, equilibrium vapor pressure. Vapor pressure yang exerted by the vapor molecule tu, bila liquid dengan vapor tu dia dekat dynamic equilibrium. So itulah equilibrium vapor pressure. Rate of vaporization is equals to rate of condensation. Okay, next. Sekarang ni kita nak explain lagi macam mana vapor pressure is exerted. So vapor pressure ni dia exert dalam closed system, dalam closed container. So this vapor molecule are in constant random motion, continually strike. So maksudnya dalam kita punya closed system kita, okay, kita ada vapor molecule, okay, vapor molecule ataupun gas molecule. So vapor molecule ni dia move constantly lah kan, dia ada constant motion. Okay, dia continually strike the container, okay, wall of the container. Dia collide dengan other vapor molecule and juga dia collide dengan surface of the liquid molecule. So bilanya ada collision dengan these three things, okay, dia akan exert vapor pressure. So every time the vapor molecule hit the wall of the container, the pressure is exerted. Sebab itulah ada vapor pressure dalam closed system. Okay, so itu pasal vaporization. Okay, so tadi kita tahu vaporization ni dia occurs in two ways. Satu yang evaporation, yang kita tahu dia occurs only on the liquid surface. Okay, dan yang kedua adalah boiling. So boiling ni dia occurs throughout the liquid. Okay, so maksud boiling point, okay, dekat sini adalah the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. So external atmospheric pressure tu boleh jadi 1 atm, boleh jadi 0.5 atm dan sebagainya. Okay, so maksud dekat sini dekat setiap different pressure dia ada specific boiling point ni lah. Okay, so apa itu boiling? So boiling dia change daripada liquid to gas lah. Dia one of the vaporization punya process. Okay, dia occur at the surface dan juga inner part of the liquid. So kalau tadi evaporation, so evaporation dia occurs only dekat surface of the liquid kan. Inner dia tak ganggu, surface je. Okay, sebab surface tu dia senang nak escape as vapor molecule. Okay, sebab apa? Evaporation process dia boleh berlaku at any condition, at any temperature and pressure. Okay, tapi boiling ni dia ada specific temperature dan pressure yang dia akan adalah untuk setiap boiling point tu. Okay, dia different compared to evaporation. Okay, so dia occur at surface and inner part of liquid untuk boiling. So dia akan observe bubble. So bubble akan kita observe lah bila ada boiling ni. Okay, so temperature remain constant during the boiling process even heat is supplied. So maksudnya bila liquid tu dia dah capai dia punya boiling point, okay, temperature boiling point tu dia remain the same walaupun the heat is continually supplied dekat dia. Okay, so boiling point ni dia occurs at specific temperature and pressure. So maksudnya dekat specific pressure ada specific boiling point, or the setiap orang kata jenis liquid dia ada specific boiling point. Okay, alright. So apa beza boiling point yang biasa dengan normal boiling point? So normal boiling point ni adalah temperature of which liquid boils when the external pressure is 1 atm, ataupun kita kata kat sini the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure of 1 atm. Okay, so maksudnya sama je lah, cuma kita maksudnya ada 1 atm ni. So normal boiling point pressure dia adalah 1 atm. So maksudnya at that temperature the vapor pressure of the liquid becomes sufficient to overcome the atmospheric pressure and lift the liquid to form bubbles inside the liquid. Okay, maksudnya dia dah capai boiling point. Okay, so apa relationship between intermolecular forces dan juga vapor pressure? Okay, so liquid yang ada strong intermolecular forces, okay, dia akan ada higher kinetic energy untuk escape daripada liquid surface. Okay, sebab apa? Kalau liquid yang ada strong intermolecular forces, dia perlukan lebih energy lah untuk overcome the forces kan, supaya dia boleh escape daripada liquid surface pergi kepada gas surface. Okay, jadi gas molecule. Okay, so more energy is needed to overcome the strong intermolecular forces between the liquid molecule. Thus, liquid molecules with stronger intermolecular forces are less volatile. So less volatile ni maksudnya dia ada low vapor pressure. Okay, so contohnya ethanol. So ethanol ni dia ada higher vapor pressure than water. Sebab apa? Water ni dia ada stronger intermolecular forces. Okay, dia ada hydrogen bonding kan. So dia ada stronger intermolecular forces. Jadi dia perlukan banyak energy untuk escape daripada surface of the liquid. So bila itu dia punya vapor pressure dia kurang lah. Okay, sebab apa? Bila dia susah nak escape daripada liquid kepada vapor punya phase, okay, makanya vapor yang dia akan release tu sikit lah. So bila sikit vapor tu, makanya dia akan ada low vapor pressure. Compared to ethanol, so ethanol dia ada weak van der Waals forces. So bila dia ada weak van der Waals forces, dia punya intermolecular forces dia weak. Okay, weaker compared to water. So bila dia ada weaker intermolecular forces, okay, jadi dia senang nak escape daripada liquid surface kepada gas punya phase. Okay, jadi bila dia senang nak escape daripada liquid phase kepada gas phase, makanya dia akan form a lot of vapor molecule dekat closed container tu kan. Jadi dia akan exert higher vapor pressure. Sebab tu ethanol ada higher vapor pressure compared to water. Okay, next kita nak relate vapor pressure dengan boiling point. So kalau liquid tu dia ada lower vapor pressure, okay, makanya dia akan ada high boiling point. Sebab apa? Dia perlukan temperature yang tinggi lah untuk overcome the strong intermolecular forces. Okay, sebab apa? Kalau strong intermolecular forces kan, dia ada low vapor pressure. So dia punya kadar untuk form vapor tu rendah. Rate of vaporisation tu rendah, sebab tu dia ada lower vapor pressure. So disebabkan itu dia perlukan temperature yang tinggi lah, high boiling point untuk overcome the strong intermolecular forces tu. Compared to liquid yang ada high vapor pressure, dia senang nak escape daripada liquid surface tu kepada gas surface tu kan. Jadi dia punya rate of vaporisation tinggi, jadi lower boiling point. Okay, so kalau nak ingat senang je. Okay, nak ingat dia punya relationship between the vapor pressure, between the intermolecular forces dengan vapor pressure dengan boiling point yang ini. Okay, so kalau kita ada strong intermolecular forces, okay, maksudnya dia perlukan more energy untuk escape the liquid surface untuk jadi gas molecule. So bila diperlukan banyak energy, okay, maksudnya the rate of vaporization tu decrease lah. Okay, rendah. So bila rendah punya rate of vaporization tu, dia akan ada low vapor pressure. Okay, sebab sikit je kan yang berjaya untuk escape daripada liquid kepada gas phase sebab dia ada strong intermolecular forces. So dia ada low vapor pressure lah. So bila ada low vapor pressure, dia akan ada high boiling point. Okay, so kalau weak intermolecular forces pula, sebab dia senang nak escape daripada liquid kepada gas molecule, dia akan ada high vapor pressure. So bila ada high vapor pressure, dia akan ada low boiling point. Maksudnya sekejap je, okay, dia perlukan temperature yang rendah untuk capai boiling point. Sebab tu dia ada low boiling point lah. Sebab dia dah senang kan, dia orang kata ini volatile. Okay, so kalau untuk high vapor pressure ni dia volatile, low vapor pressure ni dia less volatile. Okay, ini terms dia lah. Okay, so kita dah habis untuk 5.2 liquid. Okay, so I hope you understand lah this explanation video regarding the 5.2. Okay, so sekarang kita nak tengok tutorial question. So some of the questions saya dah siap tulis lah. So saya nak explain dekat awak je lah. Okay, so the first question untuk 5.2 dia kata, describe the properties of liquid. So you know that we have 5 properties of liquid, which are shape and volume. Second one is viscosity. Third one is surface tension. Fourth one is diffusion. And the last one is compressibility. This is describe properties tu. So you just take it from the notes lah. Okay, so dekat sini saya cakap shape and volume, dia has definite volume but not a definite shape, because particles are arranged closely together but not rigidly. So dia ada strong intermolecular forces but not strong enough to hold the particles firmly in place. Thus a liquid flows to fit the shape of the container. So ini saya punya explanation ataupun description untuk shape and volume punya properties. And then viscosity, saya bagi dia punya definition, which is resistance of liquid to flow. So the greater a liquid's viscosity, the more slowly it flows. So and then saya explain juga yang viscosity decreases as temperature increases. Okay, and then untuk surface tension, saya bagi dia punya definition of surface tension, which is the amount of energy required to stretch the surface of the liquid by a unit area. And then saya explain surface tension yang molecules on the surface are pulled downwards and sideways from the neighboring molecule but not upward away from the surface, and thus pull in toward the liquid. So liquid surface is tightened as an elastic film. Okay, and then saya beritahu juga yang the stronger the intermolecular attractive forces, the higher the surface tension. Okay, and then kita tengok untuk explain diffusion. Okay, saya bagi definition dia, process in which molecule tend to disperse from areas of high concentration to areas of low concentration. Okay, and then saya explain lah kenapa diffusion rate of liquid is much less than gases, because liquid molecules are closely packed and has lower kinetic energy than gas molecule. Okay, dia ada sebab apa? Dia ada stronger intermolecular attractive forces between liquid molecules compared to gases molecule. And last but not least, explain pasal properties compressibility, di mana liquid particles are closely packed and have very little empty space. Thus, it is difficult to compress the liquid. So dia akan hanya compress only slightly untuk liquid. Okay, so these are the 5 properties of liquid yang you can describe lah. Okay, for this question number 1. Okay, and then kita tengok question number 2. So question number 2 dia kata, based on the kinetic molecular theory, explain the vaporization and the condensation process. Okay, so ni pun sama, ambil dalam nota pun ada. Okay, so kita tengok dekat sini. Untuk kita explain vaporization process. So based on the kinetic molecular theory, liquid molecules are closely packed together but not rigidly. So they move quite freely and collide with one another. Okay, so bila they collide with one another tu, okay, so each molecule ni kan, each molecule of the gas ni, liquid ni, dia possess different magnitude of kinetic energy. So when the kinetic energy ni is, when the liquid molecule has sufficient kinetic energy, so when the kinetic energy is sufficient enough to overcome the attractive forces that bind them with the neighboring molecule, they will loosen themselves and escape as vapor. Okay, alright, so before that you can juga bagi definition lah untuk vaporization process kan. Dia punya definition dia apa? Allah, besar pula. Okay, you boleh bagi dia punya definition lah. Okay, so definition ni adalah liquid ni dia change into gas kan. Okay, and then kita nak explain untuk condensation pula. So condensation pun sama, you boleh bagi dia punya definition. Okay, dia adalah gas to liquid phase. Okay, so untuk condensation kita nak explain process tu based on kinetic molecular theory. Okay, so based on kinetic molecular theory, we know that some of the vapor molecule lose their kinetic energy during the collisions or when the temperature is lowered. Okay, so bila dia punya kinetic energy tu makin lama makin kurang, okay, they do not have enough energy untuk remain as vapor molecule. So bila dia dah tak ada enough energy untuk remain as vapor molecule, so lama-lama dia akan reach liquid surface and trapped by the intermolecular attractive forces yang ada dalam liquid surface tu. Okay, so if they cannot overcome the intermolecular attractive forces, so these vapor molecules will return as liquid molecule. Okay, so this is how you explain the vaporization process as well as condensation process using the kinetic molecular theory. Okay, so that's it for question number 2. Okay, now we look into question number 3. So dia kata state. Okay, soalan suruh state saja the factors that affect the rate of vaporization of liquid. So we learn that there are 3 factors, which are the surface area. So lagi tinggi lagi surface area, lagi besar lagi surface area, lagi tinggi rate of vaporization. Okay, temperature pun sama, lagi tinggi temperature, lagi tinggi rate of vaporization. Okay, and then untuk intermolecular forces, lagi weak intermolecular forces, okay, lagi tinggi rate of vaporization. Okay, tapi soalan tak suruh explain, so you have to state sajalah, tak perlulah nak explain. So ini kita just recap balik yang kita dah belajar berkenaan dengan rate of vaporization. Okay, let's look at question number 4. We proceed to question number 4. So question asks you to define the terms of vapor pressure. So vapor pressure adalah pressure exerted by the vapor molecules above the surface of the liquid in a closed container. Okay, so bila ada vapor, okay, dalam closed container, okay, maksudnya akan ada vapor pressure. Okay, and then soalan yang kedua, dia kata define the terms boiling point and normal boiling point. So boiling point is the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. So kat sini at any atmospheric pressure lah, sama ada 1 atm ke 0.5 atm ke. Okay, and then untuk normal boiling point pula adalah the temperature at which liquid boils when external pressure is 1 atm. Ataupun you can explain the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure of 1 atm. So maksudnya normal pressure ni, normal boiling point ni, dia mesti ada 1 atm ni, mesti ada 1 atm ni. Okay, so itu untuk question number 4. Alright. Now kita tengok question number 5. So question number 5 dia kata a certain amount of liquid M is placed in evacuated vessel at temperature K. Okay, sketch the graph showing the variation of vapor pressure of liquid M with time until the system has achieved equilibrium. Okay, so bila liquid kita ni dia masuk dalam vessel, okay, dia akan, okay, liquid ni kan, ni liquid M. Okay, dia masuk dalam vessel. Okay, so vessel ni dia close vessel lah kan. So liquid ni, so ni liquid M kita tadi, dia dah masuk dalam vessel. So dia akan under vaporisation kan, betul tak? Okay, so bila dia ada vaporisation, okay, vaporisation, okay, daripada liquid dia akan surface of liquid dia akan evaporate untuk jadi gas, escape from the liquid surface untuk form gas molecule. So ada gas molecule kat sini. Okay, dia ada vapor molecule. So bila ada vapor molecule akan adalah vapor pressure. Okay, so vapor pressure ni makin lama akan makin meningkat lah over time. So over time, okay, over time vapor pressure increases lah. Okay, sebab makin lama makin banyak liquid ni escape untuk jadi gas molecule ataupun vapor molecule. Okay, but dia akan achieve the state where dia achieve dynamic equilibrium. Okay, sampailah dia achieve dynamic equilibrium. So until dia achieve equilibrium. Okay, so equilibrium ni apa? Maksudnya the rate of condensation is equals to rate of vaporization. Okay, so maksudnya rate of vaporization akan constant lah dekat situ kan. Akan constant sebab dia dah capai equilibrium. So bila constant, vapor pressure pun akan constant. So bila kita nak buat graph of vapor pressure against time, so kita boleh buat graph dia. Okay, kita buat graph. Okay, so ini adalah vapor pressure. Okay, ni sekejap saya tulis balik. So ini adalah vapor pressure. So ini adalah time. Okay, so vapor pressure against time, saya cakap tadi, over time vapor pressure tu dia akan increase. Okay, dia akan increase over time until dia achieve equilibrium. Dia akan constant bila dia achieve equilibrium. Sebab dia suruh kita lukis sampai dia achieve equilibrium kan. So kita akan lukis dia. Dia increase. Okay, and then over time dia akan jadi constant macam ni. Okay, so you boleh lukis macam ni lah untuk soalan nombor 5. Okay, so that's it untuk question number 5. Very simple je sebenarnya, dia suruh sketch dia punya graph je. Okay, okay, next kita tengok last question untuk 5.2 liquid ni. Okay, dia suruh kita explain the relationship between the intermolecular forces and vapor pressure, intermolecular forces and boiling point, vapor pressure and boiling point. Okay, so kat sini saya explain one by one. Okay, alright, so saya explain yang pertama dulu, between intermolecular forces and vapor pressure. So liquid yang ada strong intermolecular forces, okay, need to have higher kinetic energy to escape from liquid surface. Okay, untuk jadi gas molecule ataupun vapor molecule. So maksudnya more energy is needed to overcome the strong intermolecular forces between liquid molecule. Okay, so liquid molecule yang ada stronger intermolecular forces are said to be less volatile. Maksudnya dia ada low vapor pressure. Okay, so kalau awak nak explain vice versa pun boleh. Okay, and then untuk number 2, nak explain intermolecular forces dan juga boiling point. Okay, liquid with stronger intermolecular forces, sama je macam yang atas, okay, needs to have higher kinetic energy untuk escape the liquid surface. Okay, maksudnya more energy is needed to overcome the strong intermolecular forces between liquid molecule. Thus, boiling point of the liquid is high, since the liquid molecules with stronger intermolecular forces are less volatile and have a lower vapor pressure. Maksudnya dia perlukan more energy untuk vapor to achieve the atmospheric pressure. Okay. And then dia suruh kita explain, okay, the vapor pressure dan juga boiling point. Okay, yang ini pun lebih kurang sama juga dia punya cara nak explain dia. Okay, so cara nak explain ini, kita kata, at any given temperature, a liquid with high boiling point will have lower vapor pressure than liquid with low boiling point. Okay, so if the liquid molecule hardly escape to form vapor, okay, so the boiling point of the liquid is high because more energy is needed for its vapor to achieve atmospheric pressure. Sebab apa? Kalau liquid tu susah nak escape untuk form vapor, dia perlukan banyak energy untuk overcome the intermolecular forces kan, and then untuk escape daripada liquid kepada vapor. So dekat sini dia kata susahlah untuk vapor to achieve atmospheric pressure. Okay, so sebab tu boiling point dia tinggi. Alright, so itu untuk soalan A1, 2 and 3. Okay, now kita nak tengok soalan B kat sini. Dia suruh kita explain relationship between intermolecular forces, vapor pressure dan boiling point. So ini yang saya ada dalam nota tu kan. So you have to just tukar yang point tu jadi macam ayat sikit lah. Okay, so dekat sini saya buat ayat. If the intermolecular forces are strong, it takes more energy to free the molecules from liquid phase. Okay, so ini from. Okay. Consequently, the liquid has a relatively low vapor pressure and high boiling point. Okay, sebabkan dia ada strong intermolecular forces, dia perlukan banyak energy untuk overcome the forces. So maksudnya susahlah that liquid molecule nak escape jadi vapor molecule. So sebab tu dia ada low vapor pressure. So bila ada lower vapor pressure, dia perlukan banyak energy untuk vapor to achieve the equilibrium. So to achieve the atmospheric pressure. So that's why dia ada high boiling point. Okay, so ini untuk question number 6. So soalan number 6 ni dia sebenarnya lebih kurang je. Cuma dia punya explanation tu dia nak tengok awak kaitkan between point ni dengan point ni. Okay, but basically cara nak explain dia lebih kurang saja untuk ketiga soalan ni. Soalan nombor 6 lah. Okay, so that is all for 5.2 liquid. So kita dah learn about the 5.2. Okay, pasal dia punya properties of liquid, pasal process of the liquid which are condensation and vaporization. Kita dah belajar pasal vapor pressure and boiling point, and kita dah belajar relationship between the intermolecular forces, vapor pressure dan juga boiling point. Okay, and then kita dah discuss question tutorial untuk semua 5.2 liquid ni. So that's it untuk this subtopic. So I hope you understand this subtopic. Okay, but jangan risau kalau masih tak faham. Okay, what you need is time. Okay, you just have to take more time untuk faham this part lah. Jangan nak panic kalau you rasa macam you tak faham, susah nak faham this explanation. Okay, it's okay. If you have any problem, you can ask me, okay, or you can ask your friend yang faham pasal ni, or you can study by yourself, read over and over again sampai you faham. Okay, so I think that's all for today. So thank you very much and Assalamualaikum. Bye.